volume to volume percent. So same principle, but you're going to use volume. So that means it should be milliliters. It could be liters, but most likely it'll be milliliters. So same thing. So it's milliliters of solute divided by milliliters of solute plus milliliters of solvent times 100. Not too bad. Okay, so determine the volume percentage of carbon tetrachloride in solution by dissolving 100 mLs of carbon tetrachloride and 100 mLs of methylene chloride in 750 mLs of chloroform. So I kind of told you how to make chloroform. It's not good. Anyway, so this part right here where it says assume the volumes are additive, that means it can all just be added together. So your volume to volume percent is, since we're only focusing on the volume percentage of carbon tetrachloride, it will be 100 mLs over 100 plus 100. Oops. Erase that. Plus 750 times 100. So 100 divided by 100 and times 100, I end up with 10.526 blah blah blah. So let's do 4 sig figs. So 10.53% for this one. Not too bad. If the solute is ethyl alcohol and the solvent is water, then another term that we can talk about is proof. So this is drinking alcohol that we're talking about here that you're able to drink. So the proof, whenever they talk about something is 100 proof or 50 proof or whatever, this is what they're talking about. So the proof of an ethyl alcohol solution is 2 times the volume percent. So if you were determining the percent volume of an ethyl alcohol solution, you just multiply it by 2. That will give you actually the proof. So for example, this is 45%. Therefore, the proof is going to be 90. So it's the percent times 2 will give you the proof. Last one, mass volume percentage. So this one's a little different. So you got to have the mass of the solute on top divided by mLs of solute plus mLs of solvent, so the mLs of the solution on the bottom. It is not necessary that you need to know the chemical formulas per se, but you got to know how to use your densities if needed. So let's look at this. Well, hopefully this example, actually times 100, my bad. So let's double check and make sure that we know what we're doing. So a solution is prepared by mixing 125 grams of benzene with 250 grams of toluene. The density of benzene is given and the density of toluene is given also. Determine the mass volume percentage of benzene in the solution. So notice how between the two of these things, benzene is a solute and toluene is the solvent, because toluene is the bigger of the two. That's why it's dissolving the benzene. So remember that the mass volume percentage is, mass volume percentage equals 125 grams on top. So this part right here is a little tricky. So what we're going to have to do is we're going to have to do some converting, if you will. So let's do this. So 125 grams of benzene. I'm going to convert this to mLs. So I'm going to use the density of it and I'm going to flip it like a conversion factor. So on the bottom is 0.8765 grams. On the top is 1 ml. So 125 divided by 0.8765 is approximately 140, well, it's 142.612. Leave it at that. So you're going to do the second on, so I'm going to put this here actually. So this number that you get plus, so I'm going to do the next one right here. So I'm going to convert the 250 grams to mLs using that. So 250 grams, so 1 ml on top, 0.8669 grams on the bottom. So this will give me my mLs. So this one is 288.3 something. So keeping my numbers from the calculator, I'm going to plug these in here so I can get the most accurate reading I can. Let's go there. So then times 100. So 125 divided by the 142 point something plus 288, all that in parentheses, if you will. Then times 100, I end up with 29.00%. Alrighty. That's it. All right. If you have any questions, let me know. Bye.